Hey everybody, it's Brad Wiggles back after a long time away. Going to do some rocket stove project. I know it's been a long time, but back to working on this project. Eventually get back to the track machine, but for now, can't bring that into the shop. Just too much space and not enough time. Been really crazy busy with work, so work and then fixing up the house, doing some yard work and landscaping. Anyways, to the project. I was thinking lots about the batch box style rocket stove that I was moving towards, and it's really not what I wanted and not what the original plan was. The original plan was to get a small scale rocket stove that would be functional I could take to my hunting camp. Got off on the sidetrack there down a rabbit hole, and we got started into a batch box design, and it got very large, and I just not going to work. It will work. It's just not the type of rocket stove that I want to work. I want it to be a top vertical fed. I want it to be continuous. It needs to be open. And I did some testing, and you guys might have saw some videos. However, it didn't go 100% as planned. I couldn't get enough drafting, and I was building it out of steel. So been watching some videos and learning a little bit more about casting. Going to make some test stoves out of refractory and built that with I watched Honeydew Carpenter, a few other people, but Honeydew Carpenter is the guy I copied the recipe from, making sodium silicate and then combining that with perlite and sand and making refractory, casting that into a stove and then test firing it. So yeah, let's get on to it. I've already made the sodium silicate. I got a couple liters of it. I've got some ideas in my head about the stove design, about how I can make it function where it didn't function before, and some of the drawbacks, and we'll go through that through the video. So yeah, here we go. So this is the sodium silicate. I've got 3.5 liters of this stuff. Lots. And I've tested it. I'll show you that. Here is my test of making refractory mix. So this was 1 part sodium silicate, 2 parts sand, 4 parts perlite. And hopefully you can get a good view of that. Turned out pretty good. So thickness wise, that's about 15 millimeters, half an inch ish. We took it and I used a propane torch on it for 30 seconds, just straight onto it or more, and it was glowing red. But interesting, it doesn't do any cracking. I mean, that was a short term, and it was only one section. This was a mechanical test. I just tapped it to see how much strength it had. So for the test stoves, my idea is I'll build the walls 1 inch thick, just strong enough really to do the testing. And when I get the final design done, I might build the walls thicker, but I'm actually thinking I'll put in some wire mesh like they use in concrete, and then stick that in the center of the whole stove so that if it does generate a crack, it doesn't fall apart. And then it's got some mechanical integrity, because if I ever do take this into the bush hunting, it's got to be strong enough to withstand the bouncing in the tub cart. So yeah, so this is the stuff I'm making, and I'm going to mold it into a stove. Now, this stove is going to have a 4-inch burn chamber, which is right at the bottom limit of everything I've seen about what's capable of running a rocket stove. Most people go bigger. I, of course, want a low heat output stove. So I'm going to put a 4-inch burn chamber, a 4-inch feed tube, 4-inch riser. But what I'm going to do this time, different from my previous tests, I had previously gone and taken the same size feed tube as the burn chamber, which then I always had trouble with backburn, and it would constantly clog up, it seemed like, and it would start burning back up the wood. And I was thinking a lot about that. Now, if I want to have a feed tube that goes up tall, the problem is it can't be sucking air from that tube, otherwise that causes too much friction. And then, of course, it's going to turn around and burn the other way. So what I'm going to do is I'm going to shrink my feed tube down smaller than my burn, my opening. The feed tube will be smaller, and then it'll be lifted off from the actual fire stove by an inch, 25, 30 millimeters, something like that. So because it's smaller and because it's taller, it'll have this big area of air that can pull in all around the wood as the wood falls in. And if you watch videos of guys running the larger earth type home heating stoves, they have a very large feed box, a 6-inch feed box, and they never fill it with wood. So that's kind of led me to the thought that the problem might be that the wood is clogging up the opening too much and they're restricting the airflow. So yeah, let's get casting one and see what happens. Here's the mold, the lower half of the mold on the outside. So got these guides are both screwed down to the base, and then this is just held in by these retainers, and of course the end pieces are screwed in. So pretty simple. My idea here is I'm going to put down the 1 inch, compact it, then I'm going to place on top the inner tube, which I'm going to make out of this 1/8 particle board. I don't know, I've had this for years. Now I found a use for it. So I'm going to make a 100 by 100 millimeter tube, 4 by 4 inch tube. It'll go from here, it'll be butted up against this side, pushed all the way up, and then left at a gap here. And then I'll make another tube, will come up at the top, and that'll all the way up be the riser. And then another tube, little one, will be this hole here for the feed tube. Now you can see I drew the outlines in the bottom of the box. So I'm not planning on getting these tubes out. I'm just going to burn them out because these tubes are just disposable. I figure if I'm going to build the 4-inch, if this is my final design, this one won't have the mesh reinforcing it. So I'll just build another one. I'll make the walls thicker, and so it'll be more beefy, and then it'll have the mesh in all the material, all different areas to keep it nice and strong in case of a crack. So yeah, for this one, when I get it all finished, I'll just burn it out. All right, here we go. The next step, we have inserts built. Here you can see a little box insert. So if you recall, we're going to have an inch of packed material, 30 millimeters. This is going to set on top of that, butt it up right against the edge here. And then I'll take and put this cutout right here. And I have built this piece to go right here, which will get screwed on. And then the chimney insert goes like so. And as I add material, I'll just center it myself by hand. I'll bring the material up flush to here, pack it. So yeah, that's it, ready to go. So let's get mixing. All right, bucket. Oh, we got sand, perlite, and goo, and gloves. So this stuff is safe, but it's very drying on the hands. So yeah, you see that some of the bottom was a different batch. That was the very first batch. It's thicker than the stuff at the top. Interesting. All right. So the ratio I'm using is 4 to 2 to 1. And I'm just going to confirm that once I get going, because I didn't write it down when I was doing that test batch. However, I'm going to check it just by the moisture, like just by squeezing it, kind of thing. That's how I did it last time. Now, mixing it by hand here. Generally seems to be the best way to do it. However, the only thing I can do to make my life easier, maybe when I'll do next batch, I'll do double. Try using this to mix it up.
Yeah, it might work with a bigger bucket. But I think you're still going to do it by hand to get right to the bottom and get the corners. Okay, there we go. Should be obvious. Now for the goo. One can of goo. I'm sure that'll be lots. Okay, let's give it a stir. Whoops, let's get you looking right down inside. Pretty uniform. Holds together very well. So definitely lots of it's enough of the goo. You know, I don't know how much this is going to do in the bottom, because once you squish it, it does squish down a little bit. But let's see what happens. The nice thing is it doesn't dry, right? So it's not like you're in a rush to make it and set it, like we're dealing with cement or an epoxy. Or okay, I'm gonna build another batch. I'll give you an update as we keep going. Okay, that is 4 batches of the refractory mix. 1 bag of perlite. You can see, I think you can see part of the bag of sand, and about 1.5 liters of sodium silicate. Really is a wet mixture. Probably could go less, but I want to keep the mix consistent for the entire mixed stove. So now I'm at the stage where I'm ready to put on this riser. And again, it's just going to sit here. I'm not going to hold it down. If I decide I need to hold it down, this is actually taller. You can't see. This is actually taller than the outside tube. So this goes over like so. I can actually put a bungee on this and hold it in, which actually, now that I'm talking about it, it's probably a good idea. So yeah, I'll screw this together and keep filling. Looks like I'm going to need another probably 5 batches to finish this off. Coming along well. Look here, hopefully you can see. Yeah, it's going really good. I've got probably 2 batches left to go. I think I only have enough for 2 batches, so I guess we'll see what happens if I end up having to stop, make sure this is done, and then just get that to whatever height it gets to. It is what it is. At least I'll know for next time. Okay, so there's the final product. We've got packed in nice. Came about 2 inches below. So I was going for 4 to 2 to the 1 to the diameter. So that's going to be short by 1 inch, which is fine. For testing anyways, to see if this concept will work. So now what I got to do is I got to leave it all assembled like this and take the bungee cord off. going to take out these 2 screws, and I'm going to take this piece off, leave the rest all on. I got to drill a few holes through this so the air can come through and burn this wood off, and light a little fire in here. Let it burn through the wood and burn the chimney off. Yeah, burn it down basically. So I'm going to get started on that, and let's see how it goes. Here we go. Gonna fire it up here. So I just took the front off and drilled a couple holes. Yeah. This is gonna obviously light on fire. It'll try to burn this, and I'll have to put it out, use some water. Once this is kind of burnt and I know it's set, I'll probably try to peel the pieces off. So yeah, my plan here, there's a couple holes at the back. My plan is to light this little fire starter and push it into the back to get the draft going, and then I'll light a fire at the front to get it burning as well. Alrighty. I'm using the head mount for my GoPro, so hopefully this is working. Just gotta let it go, I guess. Wait. Let that start burning and get that hole burning. Make sure you guys get a shot of it. Okay, I'm going to start adding some of these little bits here. Until that hole gets burnt out, it's not going to burn. It's not actually going to rocket. Let's take a look down inside. Yeah, the holes are just starting to, edges are just starting to burn. It's got to get hot. I don't think you guys are seeing much when I get my hat on. Alright, let's just stuff it full and see what happens. Of course, once in normal operation, this is the wood's getting fed this way. This is going to be sealed off with a grate. I'm going to put a grate in there. It'll be about an inch tall probably. It'll go back probably halfway, probably to at least here, and then basically when these pieces fall in, they'll be a little bit off the bottom, just so that the burn can happen kind of down, and so we'll see how it goes. Well, it's starting to burn a hole through. I'll update you in a minute. Well, as you can see, it's definitely burnt through the hole. without burning my hat in the camera. The flames are shooting out of there now. Of course, it's burning all the wood too on the way up. It's getting it all lit. Well, maybe I should get the hose out. Unfortunately, it's wintertime. Well, she's burning good now. That's for sure. Well, it doesn't seem to be catching. It was a little bit there. I put some water on it, but looks good now. Let's see what we got going on in here. Yeah, it's coming up. It's coming back towards us here. We're back, we're sitting about right there, the fire, so it's definitely getting there. Take a video up of it inside, because I can't look. I get to see after. It's definitely burning it. I'll have to go cut some more wood, I think, once it gets burnt up a little bit. It's going good. I've had to put a little bit of water on the edges of this plywood here, but it's okay. So far so good anyways. Hopefully the water doesn't affect it too much. Shouldn't, it's, after all, it was water based. Inside, of course, the burn is going well. Is obviously it's coming out the top, so yeah, it's burning just fine. Once the flame gets right out to the edge here, I'm going to start adding more wood, and I'm going to have to keep this fed for a while. Get this whole stove to cooking temperature. Yeah, so we'll see how it goes. Once I can feel temperature up here, I'll probably take the screws out and then peel back the... No, I won't. I'm going to leave it. I'll make sure it gets to over 100 degrees. Cook the water out of the sodium silicate, because it's water based. Got to get the temp over 100 degrees C on everything to make sure all the water's out. Yeah, so we'll let her go and see what happens. Well, here you can see now it's still burning up the chimney, but it's also burning out the feed hole. This I expected as well, because of course there's a whole pile of air available here and there's not enough velocity. However, I thought, what if we tried blocking off the inlet? Would it go straight into rocket mode? And as you can see, it does. Still sizzling. It's hot in there, but all the material is burnt off to a certain extent anyways. I'll let this cook some more. So it looks like this is basically charcoal now. There's still wood in there, but I'm gonna have to get it hot. Hot, hot, hot. So things are looking good. As you can see, the flames, I mean, it's still drafting, even though it's trying to burn out here. It's still pulling through and coming up the top. And the flames are licking at the top here. Of course, we still have material, and a lot of it maybe is carbon. But there's still strength there, so it just needs to get hotter. That wood has got all that mass behind it, the insulation, and it'll, as it gets hot, it'll carbonize, vaporize, and turn into to flame. This is starting to really fall apart out here, so pretty soon this should be able to do something with it. I'm gonna let it burn right out though, because I'm scared to touch anything before it's had a chance to completely get rid of the moisture and make that silicon silicon all hardened. Sodium silicate. Well, we've had some kind of failure here in the stove. If we look inside, there's a big lump of something hanging down inside, and it's hard. So I'm not exactly sure what happened, whether it just didn't get hot enough before the wood failed. But so what I did with this one is I built this morning, and this afternoon I'm firing it. So I didn't leave it to dry. Obviously, that appears to be a flaw in the design. Maybe I should leave it for a week and sit. Well, I'm going to continue the burn, and then we'll dissect it and see what happened. Okay, here we go. Looking at the stove. I was looking inside, and it's pretty obvious what happened. I'll see if I can get a good shot of it. It's hard to say whether you'll see it or not. Anyways, can you see the thing hanging down in the center? So what happened basically, I'm pretty sure what happened is the heat, of course everything's burning great, but I didn't let it dry. I was trying to do this right away, right after setting it. So the structural integrity of the wood underneath started decreasing, and of course there's weight still on it, and this is still wet and hasn't hardened. And I thought what would happen was the heat would cure enough of the skin around the wood that would be strong enough to support its own weight. That didn't seem to happen. So anyways, of course it caved in, and once it caved in, it blocked the airflow, and the burn kind of went sideways from there. So I've taken the screws off, and I'm just going to take the pieces off one by one here. I'm pretty sure it's not cured at all. I'm going to poke it here right away. So this is what it would look like if it had cured. But I'm pretty sure that this is just all going to fall apart. And there's a good view of what happened. You can see the curing had definitely happened in the first half inch, and then it's still soft. Well, maybe quite a ways in it's actually cured, but yeah, you can see the bottom of course hadn't cured at all because it was didn't get any heat. I thought this whole top would just fall right off when I moved it like that, but again, you hold it for me. Okay. Try it. So yeah, so we definitely got a good hard cure, and then still, especially the corners, is very soft. But it's solid right here still. Like it definitely got warm enough here that all the moisture evaporated out. Well, let's see if I can get this part open where this little bubble happened. Yeah, so here you can see from the side, there's the big bubble went down like this. And it just basically collapsed in the middle of it, just collapsed right down and failed that way. So, but you know what did we get out of this? We learned something, how not to do it. But yeah, just a big bubble inside there is all that was. Actually, if you point it in this way, you can see there's a hole. There's a hole right there. That was from the as the collapse happened, a bit fell down. So now what are we going to do? Going to do it again, except this time not with the sodium silicate. I'm just going to use fire bricks and test the design. So yeah, I've thought about using fire bricks for a while, and I haven't taken the step because I just didn't want to buy it. I thought this is more fun, and it is more fun. However, it's not fun when you fail. And now I don't get to test the stove, so I want to get a chance to test it. Therefore, I'm going to build it with fire bricks and just assemble the bricks and cut them if I need to make it fit the size and the shape that I want. And then test fire it and see what happens. And I don't have to worry about all this stuff. The final build of this, I think, might have to be done also in a brick style, or maybe I'll just do the exact same, but then leave it for 2 weeks to dry, and then fire it once it's had time to get some structural integrity. So yeah, so I hope you guys enjoyed the failure. I enjoyed making it. Thanks for watching.